Assalamu alaikum everyone. Today we will discuss the few terminologies of the fluid dynamics. So let's start. Viscosity. What is actually viscosity? Opposition to the flow of fluid is called viscosity, right? So we have more extra information about the viscosity, that fluid is consist of many layers in itself, because without the layers of the fluid the viscosity isn't possible. Viscosity is due to the layers of the fluid, so it should be remembered. In everyday example we can observe the viscosity, or we can say that the both in which of these liquids have the more viscous or low, having the low viscosity with respect to the other. So you can see that the right one here is more viscous. It take a lot of time to fall into the beaker with respect to the left one, right? And the dependence of viscosity, on which factors does the viscosity depends? So number one is the intermolecular force of attraction of the fluids. Intermolecular means the force of attraction between the molecules of the fluid may cause increase or decrease in the viscosity of that particular fluid. Like you can say that it is the diagram of the three different type of fluids. One is water, other is olive oil, and the last one is honey. So you can say that the water fluid falls more easily with respect to olive oil. So it means that the water molecule have the low intermolecular forces, do not have the more force of attraction between their molecules. With respect to olive oil flow a little bit difficult, a little bit different from the water, because the intermolecular force of attraction is stronger in olive oil with respect to the water, while in the honey is more viscous than both of them, which is the main reason of that is the force of attraction. The intermolecular force of attraction of honey is greater than both olive oil and the water. So we can proceed to the next point, dependence of viscosity, that is the resistance, the opposing force between the adjacent layer of fluids. So the viscosity depends also on the resistance between the adjacent layer of fluids. So what viscosity is represented by? So representation is viscosity is represented by this very particular term. It seems like the N, but it is not N, it is known as eta, right? And actually it is known as coefficient of viscosity. What? Coefficient of viscosity. So coefficient of viscosity only the dependence of viscosity, and the coefficient of viscosity only depends on the temperature of the fluid, right? When there is a rise in temperature of the fluid, so, and the fluid does not mean that it is only related to the liquid, it also involves the gases. For the rise in temperature for the liquid, we can say that for the liquid the rise in temperature, so their molecules become free to move, so the viscosity decreases, while in the gases, when there is a rise in temperature, the space between the molecules increases more and more, and the random motion also increases. As a result, the viscosity decreases, right? Then the fluid friction comes. It is another terminology important for the chapter fluid dynamics. It is the friction. What actually friction is? Friction is opposing force, right? Friction between the two adjacent layer of fluid having different velocities, means relative velocities, is called the fluid friction. It is clear from the definition that the friction between the two adjacent layers that have the two different velocities, right? So we can say that the diagram here is fluid friction. You can say that fluid friction opposes the direction of motion, right? Here comes another terminology which is nearly equal to the fluid friction, but not exactly, right? So we have to proceed. The dependence of fluid friction is number one, viscosity. Yes, fluid friction, more the viscous the fluid, the more will be the fluid friction. Number two is the relative speed. Relative speed means the difference between the speed of the adjacent layer of fluids. It's now comes the drag force. What actually the drag force is? Previously, which terminology I was talking about, that is the drag force. So drag force, the opposing force, the resistive force experienced by a body while flowing through the fluid. Experienced by a body while flowing through the fluid is known as drag force, which is actually represented by F of D. Opposing force when the body is flowing in the particular fluid and that fluid opposes its motion, so it is known as drag force. And drag force and fluid friction are nearly equal, not exactly equal, nearly same or equal, right? So here is the example of the drag force. So you can say that the fluid resists the motion of the object. So next, now see what comes. Dependence on drag force. On which factors the drag force depends? Number one is the size, shape and orientation. Size means when the size of the material or object is bulky, huge, so the large amount of drag force will be applied. Whereas the shape, for example, if the shape is spherical, less drag force will be applied. If the shape is irregular, so the more drag force will be applied on that. Another is orientation. So what actually orientation means? Orientation means the arrangement of an object in the space, or we can say that symmetry of the object, right? So this drag force depends upon on the size, shape and object of the fluid. Number two is viscosity of the fluid. So it is clear, viscosity of fluid, I have already told you that how it depends. We previously also discussed the viscosity of the fluid, right? Number three is speed of object relative to the fluid. Right, speed of the object when the object is moving through the fluid. When there is a large difference between the difference of speed between the fluid and the object, right? If there is a large distance, so the more drag force will be applied by the fluid on the object. If there is a less difference in the speed of both the fluid and object, so there will be less drag force, right? And here finally comes the Stokes law. What is actually Stokes law? It is very, very interesting and very easy, right? So here's the definition. Stokes law states that the drag force depends on the radius r, velocity v of the spherical object, right? And coefficient of viscosity, it is not n, it is eta, coefficient of viscosity. So here you should notice that in this definition, in this particular definition, it depicts that the Stokes law is only applicable to the spherical objects, right? It is only applicable to the spherical objects. You should remember that, must, right? Here is the diagram. Spherical object having the radius r and moving with the speed v, right? And you should remember that the area outside the sphere is known as the coefficient, is known as the medium. Sorry, it is not coefficient, it is the medium. It is, we can say, fluid not only includes the liquid but gases as well, right? So where we should go through the mathematical expression f of d, right? I told you that what is f of d. F of d is the drag force, right? F of d is equal to 6 pi n rv. Actually from where it came, So actually f of d is directly proportional to nRV. nRV, you already know that 6fd is directly proportional to nRV, right? So when we remove the proportionality sign, we put the proportionality constant, which actually we use a, right? I did it directly, so I apologize for that, but it is easy. So for removing the proportionality sign, we use a proportionality constant, which is a, right? A, and the value of a is equal to 6 pi. So it is the final equation. I think it may be itty difficult for you, but it's easy. So you should do practice as well, and inshallah meet in the next lecture.